generative AI is revolutionizing the way we interact with machines, and nowhere is this more evident than in the field of natural language processing. Large language models, the revolutionary AI technology that's changing the game in every industry. Take Bing from Microsoft, for example. Bing can quickly parse through massive amounts of text to provide you with accurate and comprehensive summaries of news articles, web pages, and more. It can even suggest the top most relevant results based on your query, saving you time and effort. This is all made possible by leveraging the power of language models. For creative writing, large language models are proving to be a valuable tool for authors and writers. They can generate fresh and unique storylines or help overcome writer's block by suggesting new ideas and perspectives. For writing computer software, large language models can help with writing code by suggesting autocomplete suggestions or even writing code from scratch based on natural language input. This makes programming more efficient and accessible for beginners and experts alike. They are also proving to be game changers in strategic reasoning. These models are capable of analyzing vast amounts of data, identifying trends, and making predictions that can inform critical business decisions. These large language models are now being used to assist with strategic reasoning, and they're so advanced that they can even outperform human world champions in games like Cicero. By analyzing massive amounts of data and identifying trends, these models can make predictions that drive decision-making, giving businesses and organizations a powerful tool for staying ahead of the competition. Over the past few years, there has been an explosion of development in large language models across the tech industry. These models have grown increasingly sophisticated and powerful, with the ability to understand and generate natural language at a level previously thought impossible. Today, we'll take a closer look at some of the latest developments in this exciting field. One of the latest breakthroughs in this area comes from Google with the release of their LaMDA large language model, with its ability to engage in natural conversation with a human, providing informative and relevant responses in real time.
Today, I'm excited to share our latest breakthrough in natural language understanding, LaMDA. It's a language model for dialogue applications, and it's open domain, which means it's designed to converse on any topic. And sensible responses, keeping the dialogue open-ended. Natural conversations are generative, and they never take the same path twice. And LaMDA is able to carry a conversation no matter what we talk about. You can have another conversation without retraining the model. Let's see what happened when we talk to a paper airplane.
What's it like being thrown through the air?
It's quite the experience, actually. The wind blowing against you, and the trees flying past are quite the sight. You never know where you'll land either.
What's the worst place you've ever landed?
That would have to be in a puddle. I was just barely still intact, so I was stuck there for a few minutes. It was quite annoying.
Oh, that sounds awful. Were you able to fly again?
Thankfully, I was. I had a few minor injuries to my wing, but you can't really tell unless you know what to look for.
What's the secret to a really good paper?
Google is not the only company making big investments and breakthroughs in natural language processing. OpenAI and Microsoft are also leading the way in this field. In 2019, OpenAI also released their own language model called GPT-2, which was impressive but not fully released due to concerns over its potential misuse. However, they continued by GPT-3 language model released in 2020 was a major step forward in generative AI, capable of generating human-like text and even composing poetry, but they didn't stop there. Just last year, they released a new language model called Codex, which uses GPT-3's underlying technology to generate code, and has continued to push the boundaries of natural language processing with their latest release, GPT 3.5. This new model builds on the foundation of previous iterations, but with a new twist. It was trained using reinforcement learning from human feedback, RLHF, which was also the underlying technology for their highly successful ChatGPT.
In the world of artificial intelligence, there's been one name that's been on everyone's lips lately.
ChatGPT.
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 ChatGPT has the potential to revolutionize many fields, disrupting the way we work and create. Its impact can already be seen in various industries, including education, programming, music composition, and more. Let's explore how ChatGPT is being used in these fields and the possibilities it holds for the future. In education, ChatGPT is changing the way students learn and teachers teach. With its ability to generate high-quality content and answer complex questions, ChatGPT can act as a virtual tutor, helping students with personalized learning experiences. It can also assist teachers in creating lesson plans and grading assignments, saving time and effort. In programming, ChatGPT is being used to write code more efficiently. It can generate code snippets and provide suggestions for improving code quality. ChatGPT can also be used for bug fixing and testing, reducing the workload for developers and increasing productivity. These are just a few examples of how ChatGPT is changing the game in various industries. With its powerful language processing capabilities and potential for innovation, we can expect to see even more exciting developments in the future. LaMDA is a research group that has been leading the way in the field of language models. They have made significant contributions to the development of large-scale language models and have been a great advocate for open-source technology. LaMDA has released several open-source language models, including OPT, LLaMA, and NLLB, each with a different focus. May 2022, LaMDA released OPT. OPT is a language model with 175 billion parameters that has been trained on publicly available datasets. This is the first time a language technology system of this size has been released with both pre-trained models and the code needed to train and use them. Continuing development, February 24, 2023. LaMDA released LLaMA language model. LLaMA is a collection of foundation language models ranging from 7B to 65B parameters that have been trained on trillions of tokens using publicly available datasets exclusively. LLaMA 13B in particular has been found to outperform GPT-3 175B on most benchmarks, making it a powerful tool for natural language processing. LaMDA's released NLLB project in July 2022 is a breakthrough AI machine translation project that has open-sourced models capable of delivering high-quality translations directly between 200 languages, including low-resource languages. The project aims to give people the opportunity to access and share web content in their native language and communicate with anyone, anywhere, regardless of their language preferences. In addition to these language models, LaMDA has also released BlenderBot 3, the first 175B parameter publicly available chatbot complete with model weights, code, datasets, and model cards. BlenderBot 3 is capable of searching the internet to chat about virtually any topic and is designed to learn how to improve its skills and safety through natural conversations and feedback from people in the wild. BlenderBot 3 builds on the success of BlenderBot and BlenderBot 2, which were the first unified systems trained to blend different conversational skills, such as personality, empathy, and knowledge to carry out meaningful conversations. Generative AI language models work by training a neural network on a large dataset of text. This dataset is used to pre-train the model, allowing it to understand the structure and patterns of language. Once pre-trained, the model can be fine-tuned on specific tasks, such as generating coherent and fluent text. During generation, the model uses probability distributions to predict the next word based on the previous words in the sequence. This process allows the model to generate text that is similar in style and content to the original training data. Training large language models at a billion parameter scale is a computationally intensive task that requires a massive amount of computing power. To train models of this size, researchers typically use GPU clusters with hundreds to thousands of GPUs. These clusters allow for the parallelization of computations and can significantly reduce the training time. In addition to the computing resources, training at this scale also requires careful engineering of the software stack and optimization of the training process to ensure stable and efficient training. Training large language models with billions of parameters requires not only massive GPU clusters, but also a massive training dataset of text. These datasets can range from millions to even trillions of tokens, and they must be diverse and inclusive to capture the complexity of language use. To collect these datasets, researchers often rely on a combination of sources, including books, websites, and social media posts. However, Collecting and pre-processing such massive data sets can be a daunting task that requires significant resources and expertise. Pre-processing involves cleaning, filtering, and tokenizing the text data to prepare it for training the language models. Once the dataset is ready, it can take weeks or even months to train a language model with billions of parameters on a massive GPU cluster. Despite these challenges, developing state-of-the-art language models is essential for advancing natural language processing and creating more intelligent and human-like conversational agents. For large language models with billions of parameters, the core algorithm is based on a deep neural network architecture called the transformer, which was introduced in the paper "Attention is All You Need" by Google researchers. The transformer architecture utilizes a concept called self-attention, where each word in a sentence is given a score based on its relevance to other words in the sentence. This score is used to weight the importance of each word in the sentence, allowing the model to better understand the context of the sentence. The transformer model consists of two key components, the encoder and the decoder. The encoder reads in the input text and transforms it into a high-dimensional representation that captures the meaning of the text. This representation is then passed on to the decoder, which generates the output sequence word by word based on the input representation. The encoder and decoder components are connected through a series of attention mechanisms, which enable the model to focus on the most relevant parts of the input when generating the output. This process allows the language model to learn the complex structure of language and generate coherent text. During training, the language model is presented with a sequence of words and tasked with predicting the next word in the sequence. This is achieved through a process called auto-regression, where the model generates one word at a time based on its previous predictions. As the model generates each word, it updates its internal representation of the input sequence, allowing it to incorporate context and generate more accurate predictions. This process continues until the entire sequence has been generated. The model is trained using a large corpus of text, allowing it to learn the patterns and structure of language. As a result, the model can generate high-quality text that closely resembles human language. Pre-trained language models continue to grow in size, with companies such as Google, Facebook, Microsoft, and OpenAI leading the way. These models are now measured in billions of parameters, enabling them to generate more complex and human-like language than ever before. With such massive amounts of data and computing power at their disposal, these companies are pushing the boundaries of what is possible in natural language processing. As a result, we are seeing the emergence of new and exciting applications that were once thought impossible. With the continued growth of pre-trained language models, the possibilities for natural language processing are truly limitless. After pre-training, these language models can be fine-tuned for a variety of downstream tasks such as language translation, sentiment analysis, and text classification, and much more. As we've seen, large generative AI language models have the potential to transform the way we interact with technology. With companies investing heavily in training ever larger models, the future of AI looks promising. Who knows what new breakthroughs and applications these models will bring in the years to come? The possibilities are truly endless.
In terms of evolution of the next couple years that people should be looking out for?
In terms of like evolution of where AI will go?
Yeah.
I'll start with like the higher certainty things. I think language models are going to go just much further than people think. And we're like very excited to see what happens there. I think it's like what a lot of people say about, you know, running out of compute, running out of data, like that's all true, but I think there's so much algorithmic progress to come that we're going to have like a very exciting time. Another thing is I think we will get true multimodal models working. And so, you know, not just text and images, but every modality you'd like in one model, able to easily like, you know, fluidly move between things. I think we will have models that continuously learn. So like right now, if you use GPT, whatever, it's sort of like stuck in time that it was trained, and the more you use it, it doesn't get any better, and all of that. I think we'll get that changed. So very excited about all of that. And if you just think about like what that alone is going to unlock, and the sort of applications people will be able to build with that, that would be like a huge victory for all of us, and just like a massive step forward, and a genuine